All right, hello everyone. Welcome to homework 10. We're completing the square part 2. This is all that this is. Really, we've only got one extra step, and I don't think it's too bad of an extra step. So we're just going to do 4 examples, and then you guys can do your homework, which is 7 problems. Okay, so we skipped this step here in homework 9. And now we're going to have to deal with it, but we're not going to do what this instruction says. Technically, yes, you would want to divide your whole equation to make your coefficient 1. But the whole point of us completing the square, the real purpose is to solve for x, right? It's another way to solve quadratics. But the reason we're doing it in this lab is to help you rewrite your conic sections into the form that they're asking for. And so because the goal of me teaching you this is for the conic sections and not technically solving for x, we're going to handle this coefficient not being 1 in a different manner than what they're telling us to do here. So I'm just going to jump into the first example. No, I'm not. I'm about to jump into the first example. We're going to deal with step 1 differently, but steps 2, 3, 4, and 5 are the same as what we did in homework 9. You need to isolate all variable terms to one side of the equation. So again, that's ax squared plus bx equals c. Complete the square for the resulting binomial by adding the square of half the coefficient of x to how many sides? Both sides of the equation. So that's our b over 2 quantity squared. Step 4 is to factor the resulting perfect square trinomial and write it as a square of binomials. So this is x plus technically b over 2 quantity squared. Remember, whatever we get inside the parentheses before we square it is what that ends up factoring to be. And then use the square root property. And when you use that square root property, it's always plus or minus whatever that square root is. Okay, so now let's jump into the first example. In A and technically B, when we get there, these are both in the form we need, right? You have your variable terms to one side and your constant to the other. Even though that constant's 0, that's okay. The important thing is my variables are to one side. So when you do this, because this A is not 1, look for a GCF. And I want my GCF to only be the number, because technically your GCF is 2x, right? But I want this to stay as a squared term because I'm trying to make a perfect square trinomial. So all I'm going to take out is a 2. So when I take out that 2, that's going to leave me with x squared plus 4x, right? If you distribute that back, you get 2x squared and you get 8x. So I'm just factoring out a 2. And then we're still adding something. And then equals 0 plus, again, something. Because what we add to one side, we have also got to add to the other. Keep that equation balanced. So we have my b right here is 4. 4 over 2 quantity squared. So 4 divided by 2 is 2. 2 squared is 4. Now here's where we can make a mistake. When I add 4 here, it's very tempting. Oh, that's so annoying how it moves it up. It didn't do that last video, did it? Okay. I'm just going to rewrite this now. I'm sorry, guys. Okay. bear with me, I'm sorry. Okay, factor it out of 2. We got x squared plus 4x plus 4 equals 0 plus something. Okay, it's very tempting to put a 4 in here, but I did not add 4 to the left side. If I was to distribute everything back, that gives me my 2x squared. That gets me back to my 8x, but what happens here? 2 times 4 is actually 8. So you have to be careful in these when you take out a number, because really that's 2 times 4 that I'm adding. Okay, that's the only additional step that you got to be careful about. So now this is 2 times what adds up to 4 and multiplies to 4. And that's x plus 2 quantity squared equals 8. And again, that's what we get in the parentheses, right? 4 divided by 2. So this time, before I can use that square root property, I need to isolate the squared term. So I'm going to divide both sides by 2. So I've got x plus 2 quantity squared equals 4. And now I can take the square root of both sides. So this is x plus 2 equals plus or minus square root of 4 is 2. Subtract your 2 over. And so I get x equals negative 2 plus or minus 2. Because I don't have a radical, that means we could have technically factored it. We need to simplify this answer. So negative 2 plus 2 is 0. And negative 2 minus 2 is negative 4. Okay, and again, we could have factored that. When I have 2x squared plus 8x equals 0, if I take out my real GCF, that's 2x, which leaves me with x plus 4. 2x equals 0, which means x is 0. And x plus 4 equals 0, which is x equals negative 4. So this one would have, I think, actually been even easier to solve by factoring versus completing the square, but they told me to complete the square. And it's going to give you good practice for whenever you need to do this. Okay, but when you do this in your pre-calculus class, you're going to stop you're going to end up stopping right here. But we've got to take the extra steps because we're solving. Okay, same thing here. We could solve this one by factoring, but we're going to complete the square. So, it's in the correct form. All of my variables are on one side, my constants on the other side, even though that constant's 0. My variables are on one side. That's what's important. So take out your GCF minus whatever x's are. So 3 and 30 are both divisible by 3. That leaves me with x squared minus 30x. Nope. Minus 10x plus something equals 0 plus something. So my b term is negative 10. So when I use my formula, we've got negative 10 over 2 quantity squared. Negative 10 divided by 2 is negative 5. And negative 5 squared is 25. Now, I'm not just adding 25 over here to this side. Not good. We've got 3 times 25. So be careful. So now factor. What multiplies to positive 25 and adds up to a negative 10? That's going to be negative 5. So 3 times x minus 5 quantity squared equals 3 times 25 is 75. And again, that's what we get right here in parentheses, right? Negative 10 divided by 2. So now, before I can isolate the square root, or before I can use the square root property, we need to isolate that square root. So I'm going to divide both sides here by 3. So that leaves me with x minus 5 quantity squared equals 25. And one more time, this is where you're going to end up stopping, okay, in your conic sections, but we got to go further. So now take the square root. So we've got x minus 5 equals plus or minus, the square root of 25 is 5. Add that 5 over. So I get x equals 5 plus or minus 5. Because I don't have radicals, we need to get it to 2 number answers. So 5 plus 5 is 10, and 5 minus 5 is 0. Okay, and again, we could have solved this the way I showed you that we could have solved A. And I know that simply because it comes out to 2 normal answers without radicals. All right, C and D are a little bit different because they're not in this correct form. I want my variable terms on one side and my constant to the other. So what's the opposite of minus 6 is a plus 6. We're going to add 6 to both sides. So I've got 3x squared plus 6x equals 6. So now let's deal with the fact that this A part is not 1. So I'm going to factor out a 3. When I factor out a 3, we're left with x squared plus 2x plus something. Plus something. Equals 6 plus that same something. So what goes in that blank here? Well, let's figure that out. My b is 2. So I've got 2 divided by 2, quantity squared. 2 divided by 2 is 1. 1 squared is 1. I am not adding 1 to this side. We've got 3 times 1. So I need to add 3 times 1 over here as well. So now factor. What multiplies to 1 and adds up to 2, and that's going to be 1, which is what we have here in parentheses, 2 divided by 2. So I've got 3 times x plus 1 quantity squared equals 6 plus 3 gives me 9 over here. This is where you're stopping in your conic section. That's all you've got to do. We have to solve though. So we get that squared term by itself. So divide by 3. So I've got x plus 1 quantity squared equals 3. Now squared terms isolated, so we can take the square root. So I've got x plus 1 equals plus or minus 3 is prime, so that will stay as square root 3. And then subtract your 1 over. So I've got x equals negative 1 plus or minus the square root of 3. In my last example, These are not in the correct form. I need these two on the same side. So because I already have that minus 4 over here, I'm going to bring that 8x over. So I've got 2x squared minus 8x equals negative 4. My a is not 1, so let's factor out a 2, so that a will be 1. And that leaves me with x squared minus 4x plus something equals negative 4 plus that same something. So what goes in those blanks? My b is negative 4, so I've got negative 4 divided by 2 quantity squared. Negative 4 divided by 2 is negative 2. 2 squared is 4. I am not adding in 4. If we distribute that 2, that's 2 times 4. So I'm adding in 8. So now factor. What multiplies to a positive 4 and adds up to a negative 4? And that's a negative 2. Which is what we have in parentheses here, negative 4 divided by 2. On the right side, we're going to simplify that to 4. This is where you're stopping in your conic section, but we're solving, so we're going to keep going. Divide both sides by 2. So I've got x minus 2 quantity squared equals 2. Now my squared term's isolated, so we'll take the square root. That leaves me with x minus 2 equals plus or minus. 2 is a prime number as well, so it'll stay as square root 2. And then add your 2 over. So my final answer is x equals 2 plus or minus the square root of 2. These last two in blue and red, part C and part D, these are not factorable because of that square root. Okay, that's the whole thing for this lesson. Biggest thing is just make sure what you are adding over here to the right side is the correct thing. Notice I added a 4 to that blank, but I'm actually adding 8 to both sides when I do 2 times 4. That's the biggest mistake, the easiest mistake that could happen. That's all I've got for this. So if you guys have any questions, please let me know. I'll be happy to answer any questions. Bye, guys.